guys, welcome back to New Electronics World. Let's talk about Graham-Schmidt orthogonalization procedure in this third module of DC. Okay, what do you know about Graham-Schmidt orthogonalization? Do you know what is it? Okay, in this procedure we'll be seeing S of t as well as phi of t. What is S of t? S of t will be the signals. Okay, S of t, and phi of t will be the basis vectors. Okay, so if there are n number of orthonormal basis vectors, that is phi 1 of t, phi 2 of t, etc. up to phi n of t, we can say that there will be s1 of t, s2 of t, etc. up to sm of t, where n is less than or equal to n. Okay, what does it mean, the s and phi and all these things? Yes, let's discuss about that. Okay, we can say, I'll be using the next slide. Okay, yes, this procedure have several steps that I'm going to discuss about, and as I have said, there is a number of energy levels, and there are signals from s1 of t up to sn of t. Then first of all, what is the step 1 in the orthogonalization procedure of the Graham-Schmidt orthogonalization procedure? What is the first step? The first step is nothing but take the first signal. What is first signal? That is s1 of t. Okay, s1 of t is the first signal. So we have to take that signal and coefficient and assume all the other signals as 0. Do you know what is s1 of t? S1 of t and phi 1 of t have some relations. You know that? Yes, I will explain that. Okay. Yes, we can see. Okay, I will write it here. We know that. What is S1 of t? S1 of t is equal to S11 into into phi 1 of t. Okay, S1 of t is equal to S11 into phi 1 of t. That's the relation. Okay, this is a linear relation. Okay, if we are considering Si of t is equal to Si1 into phi 1 of t plus Si2 into phi 2 of t plus etc. up to Sin into phi n of t. Okay, here we can say that S11 of t into phi 1 of t has only role in this particular situation. That is, we will take the first signal only. All others will be assumed as 0. So S1 of t will be equal to S11 into phi 1 of t. This is the first step towards this procedure. Okay. Also, we can say that phi 1 of t is equal to S1 of t divided by norm S1 of t, because phi 1 is a unit vector in the direction of S1 of t. Okay. What is this norm? Norm is, this is root of, I will be writing it with another color, root of integral 0 to t S1 square of t dt. Root of integral 0 to t S1 square of t into dt. That is the norm S1 of t means. What does this mean? This norm means, and this equation means that it is energy. Energy means root of E1. So we can replace that. This can be replaced as, I'll be replacing that here. This will be replaced by the root E1. Okay, root E1. From this we can say that phi 1 of t, the unit vector, is equal to S1 of t divided by root of E1. Okay, so this is the from this energy can be found out if this is taken to this left hand side, and so that we can say that root of E1 is equal to what? S1 of t divided by phi 1 of t. Okay, as we all know that S1 of t is equal to S11 into phi 1 of t, that we have already told. So what we can say is S1 of t is equal to S11 into, by replacing phi 1 of t, we can write this S1 of t divided by root of E1. So finally we will be getting that, I'm short noting, that is, okay, we can say that S1 of t is equal to S11 into S1 of t divided by root of E1, as I have already taught. Finally, just by seeing this equation, we can arrive at the conclusion that S11 is equal to root of E1. Okay, then I'm not discussing all the steps, because all those steps are not needed for our procedure. Okay, then next step 2 is take the second signal S2 of t and find S21, S22, and phi 2 of t. At first, from the first step itself, we'll be getting what all things we'll be getting. S11 will be getting S1, phi 1, etc. will be obtained from the first step. So from the second step, we will be getting S21, S22, and phi 2. Here we will be considering only the second as well as the first signals. Okay, all others will be that is if in the for the second signal we can consider that S2 of t is equal to S21 phi 1 of t plus S22 into phi 2 of t up to S2n into phi n of t. Am I right? So that we have to assume that except S21 and S22, all the other coefficients of the basis vectors are 0. That is S23, S24, etc. are 0. So we need to consider only the S2 of t is equal to S21 into phi 1 of t plus S22 into phi 2 of t. We just need to consider only this thing. Here, this S22 into phi 2 of t can be replaced by one thing. That is, we can replace it by G2 of t. Okay, we can replace this by G2 of t. So, this will be G2 of t. Okay, so what is the G2 of t? This is nothing but it is S22 into phi 2 of t. Okay, from this, what is G2 of t? Just by say a simple step, just we can take that this equal to sign have to be removed by minus. Am I right? And this has to be equal to. So what is the output? D2 of t is equal to S2 of t minus S1 of S21 into phi 1 of t. So we will be already having the phi 1 of t, and S2 of t will be given for you. So you have to just only calculate S21 of t in order to get the G2 of t. How can we calculate S21 from this step? Yes, I'll explain that. We have to find out S21 into phi 1 of t. Am I right? So what is S21? S21 is nothing but integral 0 to t S2 of t into the phi 1 of t dt. This is S21. This entire equation is S21. Okay, so from this equation we will be calculating S21. Then how can we find out the phi 2 of t and S2 of t? Yes, I'll be explaining that. I will get this G2 of t from this equation as from the equation that I have explained just before. So we have to calculate G2 of t, and from the G2 of t we will get phi 2 of t, because G2 of t is equal to S22 into phi 2 of t. So what we can assume from this? We can say that phi 2 of t is equal to G2 of t divided by norm G2 of t. So from this step we will be going to the similar step as that of first step. That is, what is norm G2 of t? What is norm G2 of t? That is nothing because it is integral 0 to t G2 square of t dt. This is nothing but it is the what? E2 of t. This is E2 of t. So I will be replacing that with root of E2. Okay, root of E2. No need to write E2 and all. We'll be getting S22 from this particular thing, because we have calculated already the G2 of t, and phi 2 of t will be obtaining from this equation, and using these two we will be getting what? S22. What is S22? S22 is equal to this particular G2 of t divided by root of integral 0 to t G2 square of t dt into some value, that is into divided by phi 2. Am I right? 1 by phi 2. 1 by phi 2. So all from this equation will be, on rearranging all these things, we'll be getting all the required signals. Okay, so we have to perform the next step. I think that using a problem only you'll be identifying what all the things you have to keep in mind while doing this particular type of Gram-Schmidt orthogonalization procedure. Okay, so I think I know that because these steps are not at all very easy. But before giving a problem, I have to say something about it. Then only you'll be understanding what all things we are going to discuss. Okay, so we are going to step 3. What is step 3? Similar to step 2. The third step. What is the third step? We have to consider the second signal. That is the S3 of t. Third signal. Okay. So take the third signal, and we'll be getting S31. What is the third signal? S3 of t will be equal to S31 into phi 1 of t plus S32 into phi 2 of t plus S33 into phi 3 of t. Okay, this is the third signal. All the others will be, all the S34, S35, etc. will be present for S3 of t. S34 into phi 4 of t, S35 into phi 5 of t, etc. will be present up to n. Okay, but we will be considering only up to S33. all the other coefficients will be considered as 0. The coefficients of basis vectors are considered to be 0. That is S34, S35, etc. up to S3n will be considered as 0. So, what we can get from this? S3 of t. Yes, S31, S32, S31, S32, S33, Phi1, Phi2, Phi3 of t. All these things, all the 6 things we have to calculate. Of these, what are things we have? Yes, Phi1 of t we have from the previous step, Phi2 of t we have. So, 2 of them we know. Then, what is this S31? Do you know what is S31? S31 is nothing but it is the integral of 0 to t S3 of t, as S3 will be given into Phi1 of t dt. Okay, this is S31. And what is S32? What is S32? S3 of t will be given and Phi1 will be known. Similarly, in the case of S32, S3 of t will be given and instead of Phi1 there will be, yes, Phi2 of t will be present. So what will be the S32? That also will be calculated. Then what we have to do here is we have to replace this S33 into Phi3 of t, the unknown parameter, as G3 of t. Okay, so what happens is, yes, if this is erased, I'm not writing this again. So what we can say is, yes, this S31 into Phi1 of t plus S32 into Phi2 of t plus G3 of t will be equal to S3 of t. So what we can say? We can say that, yes, G of t can be calculated. G3 of t can be calculated. What is G3 of t? G3 of t is equal to what? Yes, S3 of t minus S31 into Phi1 of t minus S32 into Phi2 of t. Am I right? Okay, by rearranging we'll get that. From that, what will be getting? G3 of t will be getting. And next step is what we have to find out, S33 and Phi3 of t. Yes, what is Phi3 of t? Phi3 of t is nothing but G3 of t divided by G3 of t, that is equal to G3 of t divided by root of integral 0 to t G3 of t whole square dt. Okay, so this is a similar step as that of the previous one. Similar step, we don't need to do any other things more than that. Okay, so we'll be getting Phi3 of t and then we have to calculate S3 of t, S33. What is S33? Yes, S33 is equal to, so S33 into Phi3 of t is what? S33 into this G3 of t divided by root of integral 0 to t G3 of t whole square dt. So we can assume that S33 is equal to what? Integral, yes, 0 to t G3 of t whole square dt. Okay, that is, I'll be showing it here. Okay, G3 of t equal to G3 of t divided by integral 0 to t G3 whole square t dt into, what is it? This is Phi3 of t into S33. Am I right? So this 2 will be getting cancelled and this will be going this side, and what we will get is S33 is equal to integral 0 to t, root of integral 0 to t G3 of t whole square dt. Okay, that's a simple thing. Rearranging we will be getting that, and these are the steps in the Gram-Schmidt orthogonalization procedure. Okay, here we can expect more problems from this section. Okay, I think this steps will be not sufficient to understanding each and everything. From the next video I will be explaining a procedure. Okay, I'll be explaining the procedure on the thing. Okay, these all are the steps only. Okay, so till the next portion you have to refer this video for more corrections and knowledge about the particular Gram-Schmidt orthogonalization procedure. This is a very important portion from the third module. A problem will be most probably asked from this section, and I'll be I'll be explaining the problem in the next video. I know that this video is but a little bit lengthy, but I think it will be very difficult for you if I am not explaining in this manner. Okay, if you have any queries or any doubts regarding this section, please do comment in the video and I'll be definitely answering to your queries as well as doubts, and the PPT for this section will be shared if necessary. Okay, or any other notes are required, I'll be sharing all those things. Okay, so do subscribe, share, like the channel. Okay, thank you.